Hello everyone. In this video, we are going to learn about silicones and which are very important. Silicones are which are very important polymers used in our daily life as well as in industries. I will explain what silicones are, how are they prepared, and their important properties and what they are used. So in your syllabus, they given preparation properties of silicones and phosphonitrile. Today's class, we will see these silicones. Silicone is one kind of inorganic polymers. What is silicones? Silicones, also called polysiloxanes, are polymers containing a backbone of alternating silicon and oxygen atoms. It should be represented as SiO(Si), one silicon atom, one oxygen atom, again one silicon atom. This is the way the silicones are represented. To each silicon atom, organic groups like methyl or phenyl are attached. So these polymers are partially inorganic and partially organic. The general formula is R2SiO(N) times, where R is the usually methyl group or phenyl group. So these are some examples they given here. In nature, silicon occurs in the form of silica, that is in form of SiO2. Silica is reduced to produce silicon metal. From silica to silicon metal, we can reduce it. Then from this metal, we can easily take it as silanes or siloxanes. From this silicon, from this metal, we can take it in the form of semiconductor silicon, that is silicon wafers, that is solar cells. Why silicones are important? Silicones are unique because they have very strong SiO bonds. This gives them extraordinary thermal stability, flexibility, and resistance to chemicals. They are hydrophobic and naturally it is electrically insulating and biocompatible, making them suitable for industrial, medical, and household use. So these silicones are used in a different way. Silicones are mostly a soft, flexible, as well as in the case of synthetic polymers. Silicon is a hard and brittle and natural minerals. There is a difference between silicon and silicon. Silicon, it contains soft, flexible, as well as the synthetic polymers. It should be made up of silicon, oxygen by the addition of phenyl or methyl groups also present in the case of silicon. In silicon, it should be in the case of metal, that mineral that is hard and brittle and natural mineral. So what are the raw materials and starting setups used for this silicone is, first we need silica, that is SiO2, carbon, methyl chloride. So the starting material is silica sand. This silica is reduced with coke in an electric furnace to form elemental silicone. This silicone reacts with methyl chloride in the presence of copper catalyzed. This industrial method is called the Dow Corning process, producing different methyl chlorosilanes like dimethyl dichlorosilane, methyl trichlorosilane, and trimethyl chlorosilane. So these are the key intermediates for making silicones. So this is the preparation of silicones. The first reaction is denoted as the hydrolysis reactions. A number of RCSiCl3s when undergo hydrolysis reactions, this hydroxyl group involved into this Cl, the Cl will be removed, then OH group will be attached. So this is the hydrolysis reactions. So in this case, here there is OH group will be react with the next OH group. The condensation will be carried out. So removal of water molecule and the hydrogen will be replaced. H2O will be replaced. This hydrogen from this silicone, from this OH will be removed from here. So H2O is removed and we'll get the silicone structure. So the second reaction is condensation reaction. So there is the elimination of water molecule within the molecule or SiOH, isn't it? So yeah, there is two methyl groups in OH. So this hydrogen and OH will get reacted and removed as in the case of water. So this is the condensation reaction, formation of silicone. This silyl group condense to form siloxane bonds depending on the chlorosilicon used. So if it is in the case of dimethyl dichlorosilane, it is a linear silicone oils. If it is in the methyl trichlorosilane, it is cross-linked silicone resins. If it is in the case of trimethyl chlorosilanes, chain stoppers controlling molecular weight. This method gives oils, elastomers, and resins. From this method, we can in three forms by using the dimethyl, methyl trichloro, or trimethyl chlorosilane. We will use it in the case of oils, elastomers, and resins. Third one is a ring opening polymerization, that is ROP. In modern industries, cyclic siloxanes like D3 and D4 undergo ring opening polymerization in the presence of acid or base catalyzed. This method gives high purity silicone oils and rubbers. From this method, we get the high purity of silicone oils and rubbers. There are some type of silicones are there. One is silicone oils, silicone elastomers, silicone resins, silicone gels. So first one is silicone oils. It is the form of low viscosity fluids. It is used in the lubricants and cosmetics. Elastomers are rubber-like materials. It is used for seals and medical devices. Resins are highly cross-linked structures. It's used for coatings, paints, and varnishes. Silicone gels also used as a soft materials. It will used in the case of electronics and medical implements. So these are the main applications of the silicone oils, resins, and gels. So some of the physical and chemical properties of silicones are given here. The first one is thermal stability. The silicon-oxygen bond, that is SiO bond strength is higher than the carbon-carbon bond. So silicones can tolerate temperatures from minus 50 degrees Celsius to plus 250 degrees Celsius because of the strength of the SiO bond. The second character is hydrophobic nature. So silicones surface repel water, which is why they are used in waterproofing materials. That's why the silicone is used as a waterproofing materials to hydrophobic in nature. The third character is electrical insulations. Silicones are excellent in insulators even at high temperatures, so they are widely used in electronics. The fourth character is chemical inertness. They resist oxidations, acids, alkalites, and UV radiation. So their stability makes them environment friendly and medically safe. The fifth character is flexibility. The wide range of SiO bond angle gives a chain flexibility, making silicone rubbers soft and elastic. So these are the main five physical characters of the silicones. The next one is applications of silicones. In medical field, it is used in the case of pacemakers, implements. Silicones are biocompatible, meaning they do not react with body tissues, but it making them safe for permanent implements. Their flexibility and stability help devices like pacemakers functions reliably inside the body for many years. Then catheters, that is silicones catheters are soft, smooth and flexible. Because of this, the reducing irritations during long term it should be used. They are also non-reactive and allow safe fluid movement without causing any infections or allergy reactions in our body. The next in medical field, the silicone is used in the case of contact lens also. Silicon based lens allow high oxygen permeability, keeping the eyes healthy and comfortable. Their lightweight, flexible structure provides clear vision and longer wearability. So that silicone is very flexible to using in the contact lens. In the case of electronics, silicones are used in the sealants. Silicone sealants protect electronic component from moisture, dust, and chemicals. They remain stable at high temperatures, ensuring long-term device protections. So it will be used in the case of sealant. The next one is cable insulations. Silicones act as excellent insulators, preventing electrical leakage even under heat or stress. The resistance to fire and chemicals ensures safe and durable cable performance. And also, these silicones are used in the thermal paste. Silicone thermal paste help transfer heat efficiently from precocious to heat sinks. So this prevents overheating and improves the performance and lifespan of electronic device. These silicones are also used in the automobile and industry applications. In automobiles, it should be used in the case of lubricants. Silicone lubricants remain stable even at extreme temperatures, unlike petroleum oils. They reduce friction and wear in mechanical parts, ensuring smooth operations. And also it is used in the gaskets. Silicone gaskets seal gaps in engines and machinery because they resist heat and chemicals. So it is very useful in the gaskets of silicones. Their flexibility allows them to maintain airtight seals under pressures. These also used in the engine oils. Silicone-based fluids improve lubrications and reduce breakdown at high temperatures. They help engines run smoothly and enhance fuel efficiency also. In construction area, the silicones how it will be used means by in the case of waterproofing agents, adhesives and coatings. So in case of waterproofing agent, silicones repel water and prevent moisture from entering walls and surface. This reduces damage, mold growth, and also increases the building lifespan. So that the silicones are used in the waterproofing as a waterproofing agents in the construction field. The next one is adhesives. Silicone adhesives provide strong bonding even under extreme weather conditions. Whether it is in the extreme conditions, the adhesive in silicones are used in a good adhesive purpose. They also remain flexible, making them ideal for joining different materials. The next one is coatings. Silicone coatings protect surface from heat, UV radiation, and corrosions. So they enhance durability and maintain the appearance of buildings and structures. These silicones are also used in the household applications. First one is baking molds, shampoos, hair conditioners. Okay, so there are very varieties among the uses. I'll just give the three applications what are mainly used in the household. Baking molds, silicone baking molds can withstand both high and low temperatures without deforming. Silicone baking molds can withstand both high as well as the low temperatures without deforming the material. They are non-stick and making it easy to remove food without residue. So these silicones are non-stick because it is very easy to remove food without forming a residue in the vessels. The second application is shampoos. Silicones in shampoos smoothen the hair cuticle, reducing frizz and tangles. The hair will be very soft because of using silicones. They form a protective layer that enhance shines and softness. They form a protective layer that enhance the shine and softness of the hair. The third application is hair conditioners. Silicone-based conditioners help in deep conditioning, making hair soft and manageable. So it protects from hair from heat damage and environmental stress. So silicone-based air conditioners are free from the protect from the UV radiations or heat damage and environmental stress. So once again, just recap what we seen today's class. So we have seen the what are the importance of what are silicones, how they should be represented as in the case of SiO, how from silica to silicone metal. silicon metal to silanes, silanes to silicone. We have seen. And what are the why silicones are important? It should be because of its thermal stability, flexibility, and resistance to chemicals. That is the main importance. So in case of silicone, it is soft, flexible, and synthetic polymers. In case of silicone, it is hard, brittle, and natural mineral. So what are the raw material need to go further steps? So how the silicones are prepared means by the case of hydrolysis reaction and the case of condensation reaction. So from the condensation reaction by based on the product way that the dimethyl dichlorosilanes means it is produced the linear silicone oil. If in the case of methyl trichlorosilane, it is cross-linked silicone resins. Then if it is in the case of trimethyl chlorosilane, it is chain stoppers controlling the molecular weight. The next reaction is ring opening reactions. D3, D4, it should undergo the ring opening polymerization in the case of acid-base catalyzed. There are types of silicones. One is silicone oils, elastomers, resins, as well as the gels. Okay, so some of the properties we have seen. One is thermal stability and hydrophobic nature. The third one is electrical insulations, chemical inertness, and flexibility. And also we have seen the many applications of silicones in medical field, as well as the electronic field, as well as the automobile field, as well as the constructions and household. So there are in between, there are many in medical field, silicones are used as pacemakers, implants, catheters, then contact lenses. In case of electronics, sealants, cable insulation, thermal pastes. In case of automobile and industry part, silicones are used in the form of lubricants, gaskets, engine oils. In the case of construction field, waterproofing agents, adhesives, coatings. In case of household, the silicones are used in the baking molds, shampoos, hair conditioners, and all those things. Okay, so it's a very important topic for your exam point of view. It's a very important topic. So kindly go through it. So to conclude, the silicones are a versatile inorganic polymers made from silica through hydrolysis, condensation, and polymerization process. It is made from silica through hydrolysis as well as condensation reaction and also the polymerization process. The remarkable properties like thermal stability, hydrophobicity, inertness, flexibility, and electrical insulation make them indispensable in today's world. Okay, so because of this character properties, chemical as well as the physical properties, because of this properties, it is indispensable in today's world for the day-to-day life in our applications. So I hope this session has given a clear understanding of the preparation and properties of silicones. Thank you. We will meet in the next video. Thank you all.